Okay, so this is a hyperbola we're going to be graphing, and we want to get it in what we would call our standard form. Now, since the x squared term is positive and the y squared term is negative, we know it's going to be of this kind of form where it's x squared minus y squared, x squared over a squared minus y squared over b squared equals 1. This is kind of the type of the shape equation we'll be talking about after we shift it, but with the shift, this is what we call the standard form, where the center actually of the whole hyperbola will be, the center will be HK. So we want to get it in this form first. So this is our standard form, or sometimes I call graphing friendly form. So we'll get in that form first, and then we'll see where we go from there. So first of all, we have to separate these. We're going to do a double completing the square process again as we went over in class. So (4x squared), and then I'll put the negative 8x next to that, and then leave a little space, and then I'll put the negative 9y squared and the negative 54y, and I'm going to put the 113 on the other side, so that's going to equal 113. And then I'm going to try to get rid of the numbers in front, so we'll just factor those out. And usually they'll come out without any problem. If there are fractions, we can deal with that, but the ones we'll be dealing with will be nice numbers. So take the 4 out here, and we've got x squared minus 2x. And I'll leave a space for the third term once I'm going to complete that square. And I'll factor out the 9. I've got y squared minus, and 9 goes into 54 6 times, 6y. Except I'm factoring out a minus, so remember that's going to be a positive. So careful there. Leave a space, and that equals 13. Okay. And now we try to kind of complete the square for both of these. So what I'm going to do is I'm going to just say square root of x squared is x. What's half of 2? 1. And what's 1 squared? Well, 1 squared is 1, so I'm going to add 1 here. But really, I'm got that 1 in a parentheses preceded by a 4, so I'm adding 4 times 1, or 4. So I'm going to add 4 to both sides. That's what I'm really doing. 4 times 1 is 4, so I'm adding 4 to this side. Now over here, I'm going to say this is y, and half of 6 is 3. So this is our standard completing the square technique. What's 3 squared? 9. So I'm going to add 9. But this is preceded by a negative 9, so negative 9 times 9 is negative 81. So I'm actually adding a negative 81 to this side, so I've got to add a negative 81 over here. So now I can actually factor this. This is a trinomial square, so how I constructed it. So I've got 4, and I've got x, these little numbers, x minus 1 squared minus 9 times y plus 3 squared, and that equals, and if I take 113 minus 81, and if I add 4, I get 36. And remember, we want this to be 1 because in our standard form it's equal to 1, so we're going to divide everything by 36. Just do that in pencil lightly so you can see. And then 4 goes into 36 9 times, so I've got x minus 1 squared over 9 minus y plus 3 squared over, and 9 goes into 36 4 times, and that equals 1. And now we have it in standard or graphing friendly form. Now we can see that the actual center is going to be will be the point, and it's opposite sign, so it's going to be 1, -3. Okay? Now the A is going to be the square root of 9, and the B will be the square root of 4. Okay, so that's going to help me as far as finding my vertices. Now, remember, if we take this and we set it, go back with after we have the shift, we're going to shift it over here. So it's going to look like this. So kind of basically my shape equation will be x squared over 9 minus y squared over 4 equals 1. Now when y is 0, you can see that x is going to be plus or minus 3. But when x is 0, y squared will equal -4, so it will be an imaginary number. So that's going to be my imaginary vertex. So when I go to graph it now, I can actually start graphing it and find these things. My center is going to be at 1, -3. So let's put that down first. 1, -3. So there's my center. And then over here, my real axis is going to be plus or minus 3. Because if I set that equal to, when y is 0, I'm going to be on the x-axis. This is after the shift, of course. So my shift is over here. So it's going to be plus or minus 3 from here. So 1, 2, 3. And then 1, 2, 3. My graph's a little bit off on there. It looks a little odd because of this line here. Okay, and then my real axis, that's my real axis. And then my complex axis is going to be plus or minus 2 up here. And these allow me to get the points for my rectangle, and that's how I'm going to get my asymptotes. So you bring these straight down. And those are your asymptotes, and you need a straight edge, and then you can draw those in. Like this. There's a dashed line for those. Okay, and then the other side. So those are your asymptotes, and they keep going down like this, and up like that. And then we know that this is going to be a point that's going to be on our parabola, so it's going to curve like this. And I'll draw it in pencil just in case so I don't foul it up, because I want to be careful that we get the shape. And that's our real axis point. And then over here, because that's our real axis, the x-axis. And that's why I use a pencil, so you can kind of shape it a little bit like this. And that's what you should get, something like this. Now if we want to find the foci, then we have to use the formula c squared equals a squared plus b squared. And that's going to give us our foci. And that's going to actually be the distance from the center that the foci are. That's the points that help determine these. Actually, the distances between the difference of the foci is constant, so that's how we actually can formally get the hyperbola. So my a squared was 9, so c squared equals 9 squared minus 4 squared. We want that to be positive, so that's why this is the bigger one. Or not 9 squared, 9, which is 3 squared. So a is 3. So that's actually 3 squared. So 3 squared, 4 squared, so b, I could actually say over here that a equals 3 and b equals 2. That's your a squared and b squared. So 9 plus 4 is equal to 13. So c squared equals, equals 13. So c equals the square root of 13. And we can approximate that by 3.6. And then there's the distance your foci are going to be from the center. So we go 3.6, so it's going to be 1, 2, 3.6. And this direction, 1, 2, 3.6. So you can see here that your foci will be at and they're going to be on this same axis. This is the real axis, so they're going to be on this axis. So they'll have a y value is going to be the same. So the y value will be negative 3 because my center is at negative 3. And then my x value will be, this one's going to be 1, 2, 3, 4.6. Remember 3.6 from the center. And then the other one will be this one, which is going to be negative 2.6. 0, negative 1, negative 2.6. Okay, so there's your foci. Now the vertices, I forgot to mention that, the vertices actually are where the hyperbola touches the real axis, so the vertices. These are going to be these points here, which are pretty easy to see. This is just going to be the point 4, negative 3. And over here, this would be what? Let's do the negative one first. So it's going to be negative 2, negative 3. And 4, negative 3. So that's actually the points where the hyperbola actually touches the real axis. Those points on that. The little points look like the vertex of a parabola if this was a parabola. Kind of the same idea. Okay. And then the last thing we have to find are the asymptotes, the equations of the asymptotes, and that's a little bit trickier. Okay, because actually the slope here of these lines, and the slope of these lines are easy because basically it's just going to be the rise over run. So what we have is we're going to be going up 2 over 3, or this one will be down 2 over 3, so m will equal plus or minus 2 over 3. So we want the equation of these two lines. Now they go through the point, the center point, which is going to be 1, negative 3. So I just have to find the equations of the two lines that go through these 2 points with these 2 different slopes. So my first one would be, so we can use y minus y1 equals m times x minus x1. And then we'll just find the equations of those lines. So we'll use still these points, so it's going to be y minus y1, which would be negative 3, so that would be y plus 3, equals, and I'll use the 2/3 first, 2/3 times x minus x1, which is just be positive 1. And then I just find the equation of that line. So I can simplify that. Then I'm going to subtract 3 from both sides, but it's going to be in thirds, so I'll make it 9/3. So y equals 2/3 x minus 2/3, and I'm going to subtract 3, or 9/3. X minus 11/3. So that's one of the equations of the asymptote. Okay, 2/3 x minus 11/3. And the other one, we're going to do the same thing, but only we're going to use minus 2/3. So it'd be the same thing. Y plus 3 equals negative 2/3 times x minus 1. Everything's the same except we just changed the sign on this. So it's going to be y plus 3 equals negative 2/3 x. A negative times a negative is a positive 2/3. And then I'm going to subtract. So it's going to be y equals negative 2/3 x. And I'm going to subtract again. So it's going to be plus 2/3 this time, minus 9/3. That's the same. But that's going to give me y equals negative 2/3 x. And this is going to be minus 7/3. And then those are, oh, sorry about that. Okay, so you see over here. So we made this change. These are going to be the same. I'm going to do the same thing, but because this is going to be a negative and that's going to make that a positive, 2/3, then this is going to be somewhat different. So those are your two asymptotes. Okay, and that's the equation of those two lines. So this is asymptote. Asymptote and asymptote. And there you go. So those are the equations of your asymptotes. Okay, so there's a bit of work on this one. Okay, hope that makes sense. And this is our standard form, of course.